manufacturing process. Today we are going to discuss about bulk deformation. It's another common manufacturing process employed to produce pipes, steel rods, etc. So the course learning outcome is to describe various metal forming processes such as rolling, forging, and extrusion. And today in this chapter we are going to discuss about extrusion and compute their process dynamics and performance. We are going to discuss the types of extrusion. What is extrusion? The types of extrusion. What products can be produced for extrusion? What metals can be used? The process dynamics, the equations used for extrusion process, like the force required for extrusion, etc. And finally, the analysis of direct and indirect extrusion processes. Extrusion means compression of metal through a die opening to produce a desired cross-sectional shape. It's a forming process in which metal is forced through a die opening to produce desired cross-sectional shape, and normally the cross-section will be uniform. So production process in which we produce uniform cross-sectional shape by forcing metal through a die opening that is called extrusion. The shape of the product to be produced will be equal to the shape of the die opening. A simple example of this is like in your day-to-day life, squeezing toothpaste out of a toothpaste tube. So when you squeeze it, when you compress it, the toothpaste will come out through the opening of the tube, and its shape will be the opening of the cap. So this means if you squeeze or compress a metal inside a chamber and squeeze it, it will undergo plastic deformation. When you force it, it will come out through the opening and it will have the shape of the opening. So such a production method where we force the molten metal, where we force the metal through an opening, a die opening, which has the same shape of the product to be produced, that process we call it as extrusion, and normally we produce uniform cross-sectional products. So we have two types of extrusion processes. They are direct extrusion and indirect extrusion. And commonly extruded materials include metals. We can extrude metals, polymers, ceramics, concrete, even foodstuffs also we can extrude. So products, normally we produce tubes and rods. It's most widely used in industries, fire extinguisher cases, shock absorber cylinders, and gear blanks. These are some of the products which can be produced by extrusion process. You can see here many shapes having uniform cross section can be produced by extrusion. You can see here several shapes. Both metal and non-metal can be produced. Rods, hollow tubes, steel rods, then structural elements, many parts can be produced like heat exchanger fins, casings, etc. So it's a compression process in which metal is forced to flow through an opening to produce a shape with a specific cross section. This process is extensively used in pipes and steel rods, and the input is the metal or material is forced through the die opening to produce the product. Extrusion can be of two types: by direction, direct and indirect. Direct means if the direction of movement of the ram and the direction of the movement of the product, if they are in the same direction, we call it as direct extrusion. That means the movement of the ram forces the material out of the chamber in the same direction. That is called direct extrusion. If the movement of the ram forces the material in opposite direction of the ram, that is called indirect extrusion. That means the movement of the material or product will be opposite to the direction of movement of the ram. Based on direction, we have direct extrusion and indirect. Then by temperature, hot and cold, if above recrystallization, we call it as hot extrusion, and at ambient condition, cold extrusion. By equipment, we have horizontal and vertical. Based on the layout of the equipments, horizontal and vertical extrusion machines. Now, direct extrusion means when the ram, we have a chamber here, it's a container. This is the metal billet. We have a ram to force the material, and there is a die. This is the die here, in here, and this is the die opening. So material is forced, compressed. Metal will undergo plastic deformation. It will get squeezed, and material will come out through the opening, which has the shape of the die. Now, if you look at it, the grain or reorientation here, as you compress and near the die, you could see the elongation of the grain structure. So here, the elongation of the material, the grain structure takes place, and material will get deformed to the required shape using this process. If the direction of ram and direction of movement of the billet of the product, if they are in the same direction, see the ram is in this direction, and the product coming out also in the same direction of the ram, we call it as a direct extrusion process. So it is also called forward extrusion, and this as ram approaches die opening, a small portion of the billet remains that cannot be forced through die opening. You can see here, whenever it reaches close to the die, some amount of material will remain inside the container, which cannot be forced out. That material, we call it as, but that has to be removed before we start the next process. Must be separated by cutting or by some other process before we start. So starting billet cross section, final shape of the extruded is determined by die opening. Now, hollow and semi-hollow shapes can be produced by this. You can see, we can see here the ram as it moves forward, and you can see here the hollow section is produced using this. The die is mounted on the ram. The material is forced out in the opposite direction of the ram movement. This is we can see here how we produce hollow shapes like pipes, circular shapes, square shapes, C shapes, channel shapes, etc. So here the die is mounted on the ram, and the material is forced out in the opposite direction of the ram movement. Indirect extrusion, if the direction of movement of the ram and the direction of movement of the material, if they are in opposite direction, we call it as indirect extrusion. So here, as you could see, the ram is moving in the forward direction, and the product will be in opposite direction to the movement of the ram. This is indirect extrusion process, which require less force in comparison with a forward extrusion, because friction will help in the movement of the product out of the chamber. Now, comments on indirect extrusion, as we see that the temperature ranges for extrusion are lead 200 to 250, aluminum 375 to 475, then copper and its alloy 650 to 975. These are the temperature ranges. Out of the steels and refractory alloys will have high temperature ranges above 800 degrees Celsius. These are the extrusion machines, and now advantages of extrusion are variety of shapes can be produced using extrusion process. One of the important thing we need to understand is the cross section must be uniform. Grain structure and strength can be increased by cold working, but hot working will give you more chance of for large deformation. More ductility can be produced, and more deformation can be produced. If you want to go for high accuracy extra, you have to go for cold working process. So thank you very much for listening. Just okay.